Cancer affects millions of people annually and is the second leading cause of death in the United States. As the number of cancer patients increase year over year, early cancer detection remains to be the best type of prevention. And with the correct medical procedure, many kinds of cancer can be prevented or caught early. For example, the endoscopy.
We are Endos-Go, and we aim to revolutionize bronchoscopy technology by taking inspiration from biological mechanisms, specifically the king snake.
Endoscopy is a medical procedure that uses a tool called an endoscope to examine the organs using natural pathways such as the colon or the lungs. Bronchoscopy is a type of endoscopy and is performed in the lungs to investigate persistent coughs and airway blockages. Bronchoscopy is also used for biopsies, which determine whether or not a mass in the lungs is actually cancerous. So a bronchoscope is a type of endoscope that uses a lighted camera to explore the lungs. Bronchoscopes are often difficult to maneuver due to the fact that they're very long and flexible. This is further complicated by the high friction experienced by the bronchoscope between the patient's airway and its outer surface. Currently, bronchoscope sheaths are typically composed of thermoplastic elastomers. These materials can exhibit high friction and make it painful for the patient and difficult for the bronchoscopist to insert or retract the bronchoscope without lubrication. To combat this, endoscopists often use various products as lubricants. These products can include PAM non-stick spray and other silicone sprays that are not meant to be used for endoscopy. Using these products can cause infection due to their interference with the sterilization process. Therefore, there is a need for a low-friction solution for bronchoscopes to facilitate the intubation and avoid infection caused by non-sterile lubricants.
Snakes navigate through narrow openings in rock and slide along rough, high-friction terrain. Snakes experience thousands of sliding cycles throughout their lifetime and still exhibit low-friction behavior and wear resistance, so scientists investigate their skin to determine how they accomplish this. Using scanning electron microscopes, nano-indentation, and reciprocating sliding friction tests, the surface of the snake skin was characterized. Scientists found that tooth-like microstructure on the outer surface of the snake's bodies reduces the friction during sliding. It does this by reducing the surface contact between the snake's body and the sliding surface.
Taking inspiration from the tooth-like microstructure of the king snake, Endos-Go aims to design a bronchoscope sheath with this pattern to optimize its mobility and minimize contact during operations. The pattern on the sheath will greatly reduce the friction experienced by the bronchoscope as it passes through the airways of the lungs. Unlike a snake, which has the majority of contact on its dorsal side with rocky environments, all sides of the bronchoscope will have contact with lumens such as the larynx and trachea. This means the pattern seen on the snake's dorsal surface must be applied 360 degrees to the bronchoscope. While the average bronchoscope is 3 mm in diameter, which is approximately 8 times smaller than a coral snake, the main mechanism of the microstructure will be the same, suggesting no potential issues in scaling up.
In order to validate the effectiveness of this unique king snake microstructure, we conducted a static friction sliding test to characterize the skin's coefficient of friction. 3 casts were produced using epoxy resin, smooth tubing which acts as a control, a coral snake, and a king snake. During the sliding test, a weight was placed superior to the cast to apply a normal force. A thin wire attached to a paper cup to the cast, and weight was progressively added until the cast began to move. Based on a 2-sample t-test, while differences between smooth and coral were not statistically significant, the differences between the smooth and king snake were, suggesting that the king snake surface microstructure informs a unique lower coefficient of friction when compared to smooth surfaces. This demonstrates viability of this pattern to reduce friction during bronchoscope insertion.
The next step of our design is to find a way to effectively integrate the pattern with bronchoscopy, including how to scale the pattern correctly to fit the size of the bronchoscope and how to make the pattern attachable to fully cover the bronchoscope. We would love to partner with healthcare professionals to give us more insight into the accessibility of this idea and make a team of pulmonologists and R&D engineers to complete the microstructure design and find the right selection of material. According to the National Cancer Institute, in 2021, there were roughly 1.9 million people diagnosed with cancer in the States, and an estimation of 600,000 of people will die of cancer. We hope with our sheaths for the bronchoscope, we can improve the overall experience and the efficiency for cancer detection.
We want to thank the following people and thank you for watching.